Hello and welcome. In this presentation we are going to look at trigonometric ratios, and in particular sine, cosine and tangent. And just as a quick revisit, because we will be covering this very quickly in the next couple of slides, you need to name the sides of a right angle triangle. The hypotenuse is effectively the side across from the right angle. The opposite is the side that's across from my reference angle, and adjacent is between my reference angle and the right angle. Now, ratio, well, what is a ratio? I like to probably think of a ratio as being simply a fraction. And a trigonometric ratio, or trig ratio if you prefer the shortened form, is the ratio you obtain when two sides of a right angle triangle are considered. So in other words, we will look at considering the lengths of two sides of my right angle triangle. So, sine simply is the ratio between the length of the opposite side and the length of the hypotenuse in a right angle triangle. So in other words, the length of the opposite side, length of the hypotenuse. And it is simply written as sine theta, where theta is my angle, is the ratio between the length of the opposite divided by the length of the hypotenuse. Cosine is the ratio between the length of the adjacent and the length of the hypotenuse. And this here is the ratio, so the cosine of my angle theta equals the length of adjacent divided by hypotenuse. Now, tangent is the ratio between the length of the opposite side and the length of the adjacent side in a right angle triangle. And there you go, tan theta equals opposite divided by adjacent. Now, just a couple of examples here where if I'm asked to find the value of sine theta. Now, straight up, I know that the ratios, my trig ratios, well, for sine theta is opposite divided by hypotenuse, cos theta equals adjacent divided by hypotenuse, and tan theta equals opposite divided by adjacent. So if I'm looking for the trig ratio for sine theta, then sine theta equals the length of my opposite divided by the length of my hypotenuse. So there you go. Sine theta equals length of opposite divided by hypotenuse. So I will put in the values here, length of my opposite. There you go, that's 8 is my opposite because it's across from my angle theta, and my hypotenuse is the 15 because it's across or opposite to my right angle. So there you go. So the value of sine theta will be 8 divided by 15. Let's look at the next one. This time, find the value of tan theta. Well, quickly we go to the ratios for tan theta. That is the length of the opposite divided by the length of the adjacent. So all I need to do here is identify where is my opposite. There's my opposite. Where is my adjacent? That ratio there, or that fraction, is the value of tan theta. So in other words, tan theta equals 7 divided by 8. And the last example, a little bit different this time. Find the value of x when cos theta equals 0.3. So you'll see here, trying to work out this length here. And I've been told that cos theta equals 0.3. Quickly, my ratio for cos theta equals the length of adjacent divided by hypotenuse. So here we go. So I will write my ratio out first, then I populate my values. Cos theta, well, I've been told that cos theta equals 0.3. The length of my adjacent is just x, it's the unknown. The length of my hypotenuse is 40. So 0.3 equals x divided by 40. Now, using a little bit of simple algebra, what I need to do is multiply both sides by 40, just so I have x by itself on one side. I'm looking to eliminate this, so I multiply both sides by 40. So I'll end up with x equals 40 multiplied by 0.3, or x equals 12. So put simply, and to summarize, the trig ratios are effectively the ratios between two lengths, or two side lengths of a right angle triangle. Sine theta equals opposite divided by hypotenuse. Cos theta equals adjacent divided by hypotenuse. And tan theta equals opposite divided by adjacent. We will be starting to use those a little bit more, I suppose, thoroughly next lesson, where we start to use our calculator to calculate side lengths and then on to angles. So until next time, good maths.